Hey folks, well, we got into functions last time around, so this time I want to get into scope. So the notion of scope is simply where something is visible in a program. So if we declare a variable inside a function, where can we see that variable? If we declare a variable outside a function, where can we see that variable? So this is the idea that we want to get into. So I'm going to talk about the two major scopes that we've got available to us so far. Later on in the course we'll be introducing more, but we've got two key ones for the moment. So we've got local scope, stuff that's visible inside a function, and we've got global scope, stuff that's visible everywhere. So for now, we'll focus on constants and variables. We'll get into other things later on, but constants and variables can each be declared either inside or outside functions. And that I'm including main as one of our functions here, right? Because that's essentially what it is. So we can either declare constants inside our functions, inside main, or declare it outside the functions. If it's declared inside a function, whether it's a variable or a constant, it's only visible inside that function and only after the point where you declare it. And so if I declare a variable x inside some function, no other function can see that x. If I declare a variable or a constant outside a function, so it's not inside any functions, then it's visible everywhere after that point in the program. So all of the functions have access to it. So we'll call these local and global. Local if it's inside a function, global if it's everywhere. So just to do a quickie example here. We'll create a couple of variables. Well, we'll create a variable and a constant. And again, if we've got a function, whether it's main or anything else, well, let's set up a little function here. Oops. Let's use our prototyping approach. So we've got our prototype. We'll have a full version of the function. Oh, let's make this a display function. And I just want to play with where things are and are not visible in our different functions. So we've got x and y declared globally. And so we can quite happily print them out. Let's throw an x and y inside main. And then we'll do the same sort of idea. Oops. Just going to do a quick cut and paste here. Yeah. Fingers won't work. So we'll print out x and y inside display. So we've got two global variables, and we're going to access, or a global variable and global constant rather, and we're going to access each of them from inside main and from inside display, just to prove this works. So we'll compile this, turn on our flags. I'm going to store this in scope. Oh, display doesn't return a value. Let's make it a void return type. All right, so we've got our beastie to compile. We can try running it, and sure enough, oops, I never called display either. Maybe I should actually think about my program a little more carefully here. So the main routine displays x and y, or prints out x and y, and then it calls this display function, which should then do the same thing. So compile again, try running it again. There we go. This time we're actually able to see both of the variables from, or the variable and the constant from inside each of our functions. So now if we go through and let's create a variable z, inside main. If I try and print out Z before I declare it, we should get a compilation error, right? I tried to use Z before I defined it, so that's not going to work. After I define it, I can quite happily go through and print it out. And of course, we played with lots of examples like this. It works out okay. There we've got our Z value there. But again, Z's declared inside a function. It's declared inside main, so it's only visible inside main. If over in my display, I try to print out Z, when I go to compile it, it's going to yell at me and say, it tells me Z was not declared in this scope. And that's kind of our clue, right? Z is declared, well, Z might be declared somewhere else. In this case, it is declared somewhere else. It's declared in main, but that's not accessible inside display. So on the one hand, we've got our global variables everywhere, local variables only in the function that they're declared in. All right. Now, again, our globals are visible everywhere. In terms of styles and habits, it's pretty normal to have global constants. If I've got a value, if I've got a constant for pi, for instance, I probably want to use the same value for pi everywhere in the program. So it's entirely likely I'm going to make that a global constant. With global variables, on the other hand, those are generally something we try and avoid. We only use global variables if circumstances absolutely require them. Using global variables instead of passing data around as parameters is generally not acceptable. So the problem is that if we've got a global variable, then any function in our entire program could be trashing the value that's in that. So if something goes wrong in our program, if there's a possibility that it's related to that particular variable, then we have to dig through all the functions in the entire program to figure out which one might be mashing the value of that variable. It also tends to obscure the flow of information, the flow of data through our program. If we've got functions calling functions calling functions, if we see parameters being passed, we can see that this value is going from here to here to here. We can see it in the parameter list for the function. We can see it in the call. We know that that data is being transferred because that data is likely to be needed by the function that we're calling. If it's in a global variable, we have no idea if that particular variable is actually going to be used by the function or not. We have no visible flow of control. We actually have to manually read every line of the code to figure out what's going on. So this is something that I'm going to be pretty sticky with for this term in terms of the code standards. Don't use global variables. I will take off marks every time I see you using global variables. So that's, again, a big thing in our standards. Towards the end of the course, or particularly in our next course, we'll get into discussing cases where perhaps it is appropriate to use global variables. But for now, far too many people try to use them as a way to get out of parameter passing, and that's not a good design practice. It's a poor design, and it's something that will be penalized. All right, so this is pretty much just an example going through exactly what I was just discussing. Here we've got an example of a program that's got a couple of global variables. It's got we've got a global constant for pi. We've got two global variables for an answer and for some user input. And so the idea is there's going to be some user input, a bunch of computation, and the display of an answer. And we're putting our values into these global variables. So maybe we've got our functions, one to get the data, one to calculate the answer, one to show the answer. None of these return values, none of these take any parameters. And so when I look at those three function profiles, I have no idea what data they're using. Right? The only way I can figure out what data they're using and what data they're transforming is by actually going through the code manually and to see which of these global variables they're playing with. And that really tends to complicate tracing through your code, debugging your code, modifying your code later if things need to change. You have no visual cues as to what the flow of data within your program is. Right? In this particular case, the main routine calls the three functions, call the function to get the data, call the one to calculate, call the one to display it. And inside, you have the details of, oh, this one's sticking something in input, this one's using input and sticking something in answer. But there's a loss of transparency here. We have no idea what's happening behind the scenes. So again, that's global constants, fine. Global variables, not okay. All right, the other side, the local variables, local constants, again, we've talked about this a bit. They're declared inside a function. They're only visible within that function. And any given function only cares about its local variables and its parameters. It doesn't know about and it doesn't care about the variables that are local to other functions. Right? It has no idea what names and what parameters, what names and what variables other functions might be using. It's entirely possible that every single function in your program has its own local variable it calls x. Right? So the first function has got its local variable x that it uses, and another one's got its local variable x that it uses, but they're all unrelated to one another. Right? Each function is just saying, well, I've got this storage space, I'm going to call it x. And some other function is saying, I've got my storage space over here, I'm going to call it x. Right? And they're completely unrelated. So anything that's local to a function only exists and is only known within that function. All right. And again, just in terms of an example, I don't think there should be any big surprises here. This is a similar idea where we're going to get a value from the user. In this case, we're going to get an integer from the user in one function. We're going to get a float from a user in another function. And we're going to return those values and eventually display them. So nothing too fancy going on here. Our main routine is going to call getInteger. It's going to go off and get a value. And we're going to store it in main's local variable a. It's going to call the function to go off and get a float. And we'll store the result in the return value in main's local variable b. And then print them out. Right? A and b are local to main. They only exist inside main. So in our two functions, they're each going through prompting the user to enter some kind of a value, reading it in, putting it in a variable, and then returning the value. So for getInteger, it's got a local variable called userInput. And again, this is local to getInteger. It only exists in getInteger. We're prompting the user, we're reading a value into that local variable, and then returning whatever value that is. In getFloat, it's got its local variable. In this case, we've also just happened to name it userInput. And we're saying, okay, well, I'm going to have my local variable called userInput. I'm going to prompt the user, I'm going to read a value into my local variable, and I'm going to return it. But again, these are local to the individual functions. UserInput in getInteger has nothing at all to do with UserInput in getFloat. So just things to keep in mind. Again, we'll do lots of practice with functions and scopes, and we'll introduce even more scopes later on in the course. But this gives you a pretty good beginning feel for when we're talking about local and when we're talking about global. All right, I will leave that one there for now.